Morning. I'm going to do a brief review of factoring polynomials. Some of you struggled with simplifying rational expressions because you were not factoring the numerator or the denominator successfully. So I want to run through factoring real quickly by just giving you 5 examples and how you would work them a little differently from each other. So example number 1. Is going to be 6x to the third plus 2x squared. Okay, this is a polynomial. It's a binomial because there are 2 terms. When you factor this, okay, so I'll just say for this one, for a binomial, you might want to look for greatest common factor. Okay, there's 2 things when there's a binomial, and I'm going to do the other one, but greatest common factor unless it's difference of squares. But right now, there's not a subtraction sign. This is not find the difference. We are adding. So we're going to just see if there's a greatest common factor. What could you divide 6x to the third and 2x squared by? Focus on the numbers first. 6 and 2, what can you divide them by? You can divide them both by 2. This is called expanded form. I'm going to factor it. I'm going to take out a 2. And then x squared and x to the third, what can you divide them both by? You can divide them both by x squared. They both contain an x squared. 6 divided by 2 is 3. X to the third divided by x squared, sorry that's a little blurry for you, is x. One more time, when you multiply these 2 together, you need to get this 6x to the third back again. Addition sign. 2x squared divided by 2x squared is 1. Okay, so this is the factored form of that. If this were in the numerator of a fraction and you were talking about simplifying the radical expression, you cannot, if there's a line here, cross this off with something down here until you have factored form. Okay, I have been seeing lines of things like through this or through this, but when there's an addition or a subtraction sign here, this has not been factored. These are not factors. These are not factors. You have to write it in factored form. When it's written like this, you are multiplying the 3x plus 1. This is one factor. One factor. And 2 times x times x. This now could be crossed off with something in the denominator because it is not being added or subtracted to anything else. It is being multiplied by this. Factors. Not factors. Not factors when there's an addition sign in the middle here. Okay, over here these parentheses signify I'm multiplying this by this. All right, sometimes I talk too much. So example 1, find the greatest common factor. You had 2 terms. Example number 2. I'm going to call this a trinomial with a leading coefficient of 1. You need to know what the problem looks like before you decide the method you're going to use. Okay, so this problem, if I write x squared minus 3x minus 10, when you don't see a number in front of the x squared, it is a 1. How do you factor this trinomial? Okay, so I'm going to write a line down the middle. Expanded form, factored form. Expanded form, I'm going to factor it. No number in the front automatically allows you to put x's in the first position in your parentheses. Then you find your 2 numbers, blank times blank equals negative 10, blank plus blank. I've seen this on a lot of work. This looks good. Equals negative 3. 10. Okay, so your 2 numbers should be negative 5 and 2. When you multiply them, you get negative 10, and if you add them, you get negative 3. It doesn't matter which one you put in which position on this side. Okay, but this is the factored form of this. You cannot cross pieces of this off with something in the denominator. You cannot cross pieces of this off with something in the denominator. You need to factor it when it's in factored form. Over here, there are two factors. 1, 2. You can cross this off as one piece with another x minus 5 if it were in the denominator. You can cross this off as one thing, one factor, with something in the bottom. Cannot cross this off singly with anything. Cannot cross this off singly with anything. I'm hoping this helps. All right, my third problem. Again, you can pause anytime you want. Is going to be trinomial leading coefficient larger than 1. Okay, I'm going to use 3x squared plus x minus 2. This one is a little trickier. When you have a leading coefficient that's larger than 1, you need to multiply it by the last term, which those equal -6, right? So you need to find two numbers that multiply together to make a -6, and that add together. In this case, there's 1. So your numbers should be 3 and -2. However, when you find your two numbers in this case and you go to factor, I have a few more steps. These two numbers, they go in the middle. You rewrite this first term, your 3, positive 3, and your -2 become two middle terms in the middle of a 4-part polynomial or 4-term polynomial. I'm going to make the 4th part by grabbing this very last term from the original problem. Okay, so one more time on when there's I'm not finished. When there's a number that's not 1 in front of the x squared, multiply this first term by the last, well, really the coefficient. So 3 times -2 is a -6. Two numbers that multiply together to equal -6, but add to the middle, which is 1, are 3 and -2. You put those two pieces in the middle with the first term from the original problem and the last term from the original problem. You end up with 4 terms. On any problem that starts with 4 terms or eventually leads to 4 terms, when you have 4 terms, separate them. So that you can factor further, okay? So I'm going to separate the first 2 terms from the last 2 terms. And I'm going to factor this first binomial just like I did up here when it was a binomial. So I'm looking for a greatest common factor, which in this front part would be a 3x. 3x times what equals 3x squared. Think of it that way. Or 3x squared divided by 3x equals x. Again, these two multiplied together equal this, or this divided by this equals this. So 3x times 1 equals 3x. I have promised you that when you have two binomials and you're factoring each of them, when you have a 4-part polynomial, this second part in parentheses will always be the same, exact same. So what can you divide this by to get this? -2. These come together. And you write the x plus 1, which you see appear twice, but it is the same. Okay, so this is the factored form of this original polynomial. This was the factored form. This factored form. Okay, my last example. Oh, actually, I'm sorry, I have two more. Okay, I have difference of perfect squares. I feel like you're pretty good with this one, but you do have to know what's what and how do you recognize them. So you have a lot of studying to do if you haven't memorized some of this. That's maybe why it's not coming quite so easy. You know, do you know what to do when you have a binomial? What do you do when you have a trinomial with a known number, which really is a 1 in front? What do you do when there's a number larger than 1 in front? How do you do when there's a binomial, there's no greatest common factor, and oh, this looks like difference of squares. So difference of perfect squares, when it's just x squared, x, square root of 49, 7. One's a plus and one's a minus, though I have seen some of you with the same sign in both of those. Okay, so there's really no work to show. I feel like that one, and I said you're pretty good at that. Okay, there are 4 examples. I have one more. I'm sorry, I'm going to have to use another piece of paper. I think I need another sheet. So example 5 is going to be some kind of combination. I could do a lot of these, but combination maybe of the first 4. Maybe you need to factor more than once. So I have an example that looks like 5x to the third minus 5x squared minus 60x. And we're factoring, okay? So again, this is called expanded form. We are factoring. What you have to do, you need to factor. So this process, these 5 things I'm showing you, you will need to do. All right. So greatest common factor first. Really with any of the methods, if there's a greatest common factor in all your terms, you need to do that first. So greatest common factor first. I explained this in chapter 10, lesson 8, if you want to go back and review that. So let's take a look at your 3 terms. You have 5x to the third, negative 5x squared, and negative 60x. Could you divide them all by something? Do they have a common factor? I can divide this by 5, and by 5. They all 3 terms have at least one x, so I'm going to factor out a 5 and an x, meaning you're dividing this by 5x. Divided by 5 is 1. Dividing by x will leave you with x squared. Don't forget the negative sign here. A negative 5 divided by 5 is a negative 1. X squared divided by x is x. Negative 60 divided by 5 is a negative 12. Okay, you aren't finished in this one. You're left with a trinomial, and you should question whether or not you can factor that. So look at this and go back to your first 4 examples. Which one is this like? Similar to example 2, the leading coefficient is 1. It's a trinomial. It has 3 parts. Can I factor this? And then don't forget that this 5x is still here. It's been factored out. Are there 2 numbers that multiply together to give you negative 12 and add together to give you a negative 1? they should be -4 and 3. So your factored form but I had to factor more than once. I factored out a greatest common factor, and then I factored a trinomial with a leading coefficient of 1. I'm going to talk solving a second, just in one of the sections when you had to solve these problems. Solutions then, what would make this 0? -3. Solution, what would make this 0? +4. 4 minus 4 is 0. Don't forget this though, turning this into 0, x would have to equal 0. So my solutions would be 0, 4, and -3 if I had to write solutions for this polynomial. Okay, factored form. Okay, so that's pretty much factoring. I am going to teach you how to add rational expressions today. That means fractions. We're going to add fractions, and you will again be needing to simplify rational expressions, and you will have to factor. All right, take care.